Hi, I'm Scott Hughes. What we're going to get started with today is going to be the E22 error code for you on the LVG fryer, the EEG fryer, and it's also an error code that you will find on the Evolution Elite Electric and the LOV electric fryers. Although today I'm just going to cover the E22 error code, no heat, on a gas fryer. So when you're dealing with an E22 error code, one of the first things that you need to do is find out what is the oil level. So maybe you're not very familiar with the E22 error code. Well, let's take a look. Okay, so we can see on there when the error code came up saying E22 no heat, and then it said check MV or burner. So it's talking about your main burn or your burner system to find out what could be going on with it. Well, a couple things with it. First off, I always tell everybody whenever you're going out on an E22 error code and you get a call in from a customer, you want to make sure that they check the oil level. So real quick, let's take a look. The logic behind a E22 error code, it's looking for a rate of rise of temperature from your temperature probe. Right here's your temperature probe. You have a level probe here and here. And then you can see the oil within the fry vat. And these are your heat exchange tube that pulls the flame through to heat the oil. And what can happen is if the customer doesn't have it full of oil, so I have oil covering my heat exchange tubes, but my temperature probe is not in the oil, it's looking for a rate of rise in temperature on a cold start for 120 degrees and below. It's going to check for 7 minutes. You know, it could be right at the on time for the heat system to be kicking on right around 3.5 minutes. But it's expecting a rate of rise in the temperature. Well, if the temperature probe is not in the oil, then it's only reading the ambient air temperature, and you could get the E22 error code. So that's why it's very important. The first thing you need to do if a customer calls in is have them check to see how much oil they have in their fry vat and that your temperature probe is in the oil or it's covered. So really what ends up happening is the control's doing everything it's supposed to do. It's we got our pilot flame sense, so then we have our voltage coming from our ignition module going back to our control board. Control board's closing a relay, allowing that 24, 25 volts to go out to the gas valve. Gas valve's opening up. It's turning the heat on, but we're never getting the input from our temperature probe because it's not in the oil. So that's the first thing you want to do. So let's take a little closer look at the logic behind the E22 error code. If it's below 120 degrees Fahrenheit or 49 degrees Celsius, it's going to take a little bit longer to check, like 7 minutes, because it thinks it's cold oil, right? And if it doesn't see a rate of rise, then you get the E22 error code. If it's above 120 degrees Fahrenheit or 49 degrees Celsius, then it's only going to do it for about 5 minutes, looking for the rate of rise of temperature. If it doesn't see it, then you get the E22 error code. So the first thing you want to take a look at before you even bother going out to the location is to make sure that you have the right tools. So let's take a look at the tools we would need and the components to take with you so you can get a first time fix rate. So on my left here, definitely need your voltmeter because you can end up checking some voltages. You have your 3/8 nut driver, or you could use a socket ratchet. And then you have your 7/8 wrench, Phillips screwdriver, flat blade screwdriver, another 3/8 wrench, just in case for reach with it. And then this is something that I find very handy whenever I'm dealing with connections as far as electrical, spade connectors. You have your needle nose pliers, but they're angled. That's really nice for clamping on and just kind of working the wire off. The problem is if you pull on a wire to pull the connector off, sometimes you could pull the wire out. So you don't want to do that. You get that underneath there and you can pop it off. And then of course you need a little stress relief, and then you got this little guy here. That's not mandatory. I just threw that in there for fun. Get stressed and you give that a squeeze. All right, gas valve. You could possibly need just the gas valve coil. Okay, so it could just need the gas valve coil, and potentially you might need to bring out a control board. You want to make sure you take a control board just in case, in the event that it's not sending the voltage on from the ignition module out to the gas valve. So always think of our supply voltage for our main burn on our gas valve is coming from our ignition module. Okay, so the first thing we want to check then is going to be our oil levels. We have to get the input from our temperature probe. That's going to tell our control board that we're seeing a rise in temperature, or a rate of rise in temperature in a certain amount of time, you know, and then if not, you'd get the E22 error code. Let's say we've already discovered that the oil level is correct, so we have the right amount of oil. So now we got to move on to phase 2 of what we could check to see what's going on. So a simple thing that you can check, you may even be able to have the customer check this, have them go ahead and check the atmospheric equalization hole. What is that, you wonder? Well, let's take a look. So the atmospheric equalization hole is this right here. And you can see the hole right there. And actually, if you were to remove this, this is where you can gain access to get inside here. And you could go ahead and adjust your gas pressure. Now, when you're at the location, and if they go ahead and they remove this cap, or the atmospheric equalization hole, it gets removed, and all of a sudden it starts heating up, the burner comes on, it's pretty safe to say that then the atmospheric equalization hole right here has gotten clogged. So this goes horizontal, and then you have this little itty bitty pinhole down in here that you see that is going to be going down in. And how that works and why that's an issue if this gets clogged. So this is for my main burn, and this is for my pilot. And if this gets clogged, well, then you have this diaphragm in here. You can see the diaphragm kind of going across. And if it's not allowed to equalize the pressure as it opens and closes, well, then it's going to could stick, and then it's not going to allow the main gas and stuff to go out, or your pilot could end up slowly fading away, or just not getting the main burn, allowing the gas then to flow on out. Now then you've got to ask yourself, you've got to wonder, well, where's all the oil coming from? It could be that the oil's coming down, leaking maybe from a temp probe or from your high limit probe that goes into the fry vat. You need to investigate a little bit more to find out where the oil is leaking from. However, if you find out that they're getting oil on this because of issues where they're sloshing oil around underneath the unit, especially over by your jug in the box, is where they hook up their quick disconnect for their fresh oil. This could get covered with the fresh oil and start to clog it. Now, what you can do then is, and this is a field fix that came back from some of the technicians, is they take a 5/8 or I think it's around 15 millimeter hose, okay? What is that, about 3 inches long? And then you can take a hose clamp, take your hose clamp, you're going to slide that up on there, and then you can go ahead and run this down and tighten it. Now what that's going to do is, one, and this is after you've cleaned it, one, it's going to allow for you to go ahead and prevent oil from clogging your atmospheric equalization hole or your breather hole. And it's wide enough around the one stem, it's going to still allow for air to flow into it. But that's only on locations where they continually are getting oil on it. This is kind of a solution that you can do out in the field. So what did we say? Check our oil levels first, right? And then number 2, we could have them go ahead and check to make sure that there's not anything going on with their atmospheric equalization hole. So make sure that's clean. If it's, as soon as they take that cap out and all of a sudden you get the main burn coming on and things are working good, it's a good chance that it's dirty and needs to be cleaned. If you have repeat issues with the oil, then we have that field fix that some technicians have informed us about that they've been doing, and it seems to be helpful. So there's 2 things that we can go through with it. Now let's take a look on the control board, and we'll start seeing how we can troubleshoot then if that's not the issue. 1, we have the correct amount of oil in the fry vat. 2, if we're looking at the atmospheric equalization hole, that's not clogged up. So now we want to start taking a look and see what is going on component-wise as to why our main gas valve is not coming on. I'm going to go ahead and explain it a little bit before I turn it on. That way it's not too noisy as I'm speaking. So you want to watch the heat light. When I turn the unit on, the heat light should be kind of pulsing slowly. That's because it's waiting for our fan or our blower motor in the back to get up to the RPMs to close the pressure switch to go ahead and start our heat sequence. The next thing you're going to see, it should blink fast, meaning that it's sparking to light our pilot. Pilot's going to light, and then from there you should have it stay solid on or off each time that it's calling for heat. So that's when your heat should be coming on. So let's turn it on. Slowly, blinking rapidly. We're sparking. Now it's solid. So now it means that I have my flame sense, my pilot's lit, so now it should be calling for heat. At this point I could get my voltmeter out and I could start checking some voltages, but while you're here you can get into what we call our HP info mode. It's simple to remember, it's just these two outer buttons, filter buttons. If this is on a Evolution Elite gas unit, you can move buttons up here, but it's always going to be the two outer buttons. So they'll be labeled different, but just remember these two outer buttons. Press these two, it's going to get you into info mode or kind of a diagnostic mode. Press those two buttons, and we could check our E-log just to confirm. That's a good practice to make sure you're on the correct VAT, whether they're having the issue with the E22 error code. So you can scroll down. Here it's telling me August 17th at 11:29 a.m. We had a E22 error code, and this R here tells me it's on the right hand side. This is a full VAT unit, so it's always going to give that. If it was a split VAT, it could have an L here for the left hand side. Let's say you get out there, you don't remember what these error codes are, you can always press the number one check mark, and it tells me, oh, it's a no heat error code. So confirm the error code. That's best practices on that part of it. So let's go ahead and scroll on over, and I want to go to my outputs test. So this has to do any of my outputs for my heat system, and we'll go through this quickly here to explain it. So I'm looking here to see that the F is for my fan. This little decimal here is telling me that my pressure switch is closed. So I reached the right amount of inches of water column for my pressure switch to close, and I can go ahead and start my heat sequence. The S has to do with my safety solenoid for international group. So you have a safety solenoid. We don't use it here domestically. So that's telling me it's energized here. Now the I is for my ignition module. So I've started my ignition sequence. That's what the little asterisks telling me. The decimal here is telling me that the flame sense has been met. Now I say that, but in all actuality or reality of it is, it's telling me that I have flame sense, but the only way that I'm going to get this decimal to come here is I reach 1 microamp of flame sense from my pilot, which then is going to allow the 24 volts to come from my ignition module and go out to my control board. And that is my source of power or voltage then that the control uses to send voltage out to my gas valve. And then you'll notice here the H then is going to be for heat or for my main burn, and every time the green LED light comes on, then I get my little asterisk beside here telling me that it's closing the relay on the board and allowing the voltage then to go out. We want to go ahead and check our voltages, so what I'm going to need to do then is I'll go ahead and grab my Phillips screwdriver. I'm going to loosen this, backing that off a little bit. Dropping this down, pushing up here on the bottom to support it, and then I can hinge it so it's going to hook onto it. We're going to set it to AC voltage. But where I need to check my voltages then to make sure I'm getting my 24, 25 volts going out to my gas valve. First off, I can go ahead and check. We have the white wire right here, and then we have this blue wire. So it's going to be these middle two right here on the diagram. So if you forget this and you're trying to remember which two, you got to check it. It's going to be your white wire, blue wire. That's going to be out for your pilot. So I'm going to stab in here across my common and across here on the middle wire. Tell me they got my voltage on out. And then if I want to go ahead and check across my common, which is the white wire here again. I'm going to check across here for the red wire then, which is going to be for my main burn. RM right down here, main burn. And right now, we don't see anything because my green light's not on, it's not calling for heat. So let's wait and see. There we go, relay closed, it's sending voltage out. And we know then that we're sending our voltage out to our main burn on our gas valve. If we know that we have our voltage going out, and one of the things you want to make sure you do where you can check it is you can also go down into the gas valve. So I've already unhooked the wires here, and that's why we're not getting the heat to come on, but it's these two wires. You can go ahead and stab into the wires. So you can stab your leads of your voltmeter into the wire. Why is this important to do it that way? Well, if I had this hooked up, let's say I had these hooked up, and I'm checking my voltages from here back at the control, and I'm seeing a drop in voltage, it doesn't mean that the control board is bad. It's a good possibility that this coil over here is bad, and it's pulling the voltage down. It's pulling the voltage down and causing the issue with it. Get this to stay, it's not going to stay. Put my leads in there, wait for it to call for heat, calls for heat, and I'm getting a good voltage, 25 volts out to it. So now I could go ahead and check then and see what's going on then possibly with my solenoid to my main burn on my gas valve. Now what I can do then is ohm it out, comparative ohms to check the resistance, which we're going to go ahead and do up on the workbench. Got my hand everything, hinge it, get here, drop it down, push up. And then I'm going to go ahead and tighten this up. Put our voltmeter then to ohms, and we could ohm it out, do comparative. So right here then is for our main burn. It's right at 7. We go over here, then check for our pilot. It's right around 5.8. So they're comparative, they're fine. Really what you want to look for to find out if it's a bad coil before you go to replace it is it would probably come up and read open. Now let's say you do have a bad coil for your main burn. So this is how it's going to set in the fryer, like so with it. But what you could end up doing then is need to replace the coil, and you can get a hold of see if you can see how I'm doing this, but I'm going to try and pull that clip off. I get the clip off, right, remove the coil, the bad coil, get the new one, put it on, get my clip right here, give the arc clip a little bit of a squeeze, get it in place, and then we're good to go. Remember I said you could use these then to pull the wires off if you need to because they're tight. Then you have your 3/8 wrench or a ratchet or your nut driver. That's to get to the 3/8 nuts that holds this whole gas valve to the shroud on the fryer. So this would be underneath where you're reaching up to get to this. So that's why you need your 3/8. And then you have your 7/8 to where you can go ahead and break the line loose here that goes out to the manifold. There again, you want to make sure that you have your gas supply shut off to the unit if you're going to have to change out the gas valve. Why would you need to change out the gas valve? Well, if you get your voltage to your coils here and everything's energizing these ohm out comparatively good, that they're not bad, then we've got something internally going on bad with the gas valve, as long as you check to make sure that your atmospheric equalization hole or your vent hole here is not clogged. Main burn, pilot, and then our safety solenoid. And just because we can, let's just go ahead and ohm out our safety solenoid for the international group. Ohm out then for our international group right around 5 ohms. Now there could be some different types of coils. There may have been some changes over the time, but there again, like I said, if it were to go bad, usually it reads an open reading. Okay, So that's the E22 error code. Pretty simple. One of the things you're going to want to go ahead and look for on it is, first thing, check your oil levels to make sure that the temperature probe is actually in the oil to get the rate of rise of temperature that we need to avoid the E22 error code. Number two, if for some reason it's heating up, we got plenty of oil in it, the temperature probe's in the oil, then we want to take a look at our atmospheric equalization hole. So we want to make sure we take a look here to make sure that this isn't clogged up. If it is clogged up, we need to remove it, see if our heat system kicks on and starts burning and we're good to go. We also mentioned if the location is constantly getting this covered with oil, then a field fix is to put you a 5/8 hose on there with a hose clamp, right? And then we found out that if that's good to go, we want to go ahead and check and see component-wise, go make our voltage checks to see what type of voltage we have, if any, going out to our gas valve. If we have voltage going out to it, then we want to make sure that we ohm out our coils on our gas valve to see if it's bad. And we showed then how you can replace that. And also, we want to go ahead and make sure then if we don't have voltage going out of our control board, then it could be a faulty control board that needs to be replaced. Okay, so the solenoid, gas valve solenoid we talked about, the gas valve itself, the control board. We'll go ahead, I'm going to share screen because I want to show you where you can go to hennypennyhelp.com, and then if you're needing these components, you can get the part numbers. And then from there, you can go ahead and type in, let's see, the model, LVG, and we know it's a gas valve. We'll click on search. We can see gas valve 200 series. We'll click on that. And then it's going to go ahead and pull up, and we can look and find out different parts, different components. If we have the solenoid is bad, it's a 24-volt AC coil on it. So that's a part number you could use for it. Now, in the event that you have to replace the complete, if you have to replace the complete gas valve, or in this case we're showing the CE International one that has a safety solenoid, you would go on down here, and then you want to make sure that you get whether it's natural gas, or if it's going to be propane. Okay, so that's it. That's all there is to troubleshooting the E22 error code. It's pretty simple. Either that maybe they don't have enough oil, so our temperature probe's not in the oil to measure the temperature. We know that it's looking for a rise in temperature. During the day that we get an E22 error code is if the end user were to go ahead and drop some product, didn't hit the cook timer button, so it's not trying to call for heat, but it's not seeing the heat going up. That could be a possible issue with it. Now, once we've discovered that we have the right amount of oil in the unit and we know that our atmospheric equalization hole is not clogged with it, we know then that we need to go ahead and start checking components. We could go ahead and just turn the unit on, make sure that we're seeing the sparking, the lighting with it. You're going to drop down your control panel, and then we need to check to see that we're getting our 24, 25 volts AC going out to the coil of our gas valve to make sure that it's energizing it, should be opening it, and then allowing for the main burn. So, to recap one last thing, you want to make sure that you realize on this, when it's going through the heat cycle and it's heating up, and you get the E22 error code, it means that the control board's doing everything it's supposed to be doing. It's just not seeing a rise in temperature. So either the probe's not in the oil, or our gas valve's not opening up and allowing for the main burn to go on out to raise the temperature of the oil. All right, so that's it. I hope you found this to be useful and helpful, and until next time. Technology, you gotta love it. Okay, perfect.